Let's talk about the global aerospace industry, because right now, it's at this incredible tipping point. You've got the digital world, all code and AI, colliding head-on with the physical world of metal and manufacturing, and it's changing everything.
To really get a sense of the pressure cooker this industry is in, just look at this number, 14,000. That's how many commercial airplanes are on back order right now. It's a sign of absolutely soaring demand. But there's a huge catch. A full decade. Think about that. The industry has basically slammed into a physical wall. They just can't build planes fast enough. Supply chains are a mess, and there are major labor shortages. So, with the physical world tapped out, the industry is looking for a digital rescue.
And that rescue is coming in waves, with the first one being artificial intelligence. But here's the thing, AI isn't some magic wand. Its impact is actually splitting, creating two completely different new fronts, one in commercial aviation and one in defense.
Okay, this is where it gets really interesting. On the commercial side, airlines are using AI as an offensive weapon to make more money, fixing flight delays for us and creating super personalized ticket prices. But on the defense side, whoa, AI is becoming the new center of gravity for warfare itself. We're talking autonomous drone wingmen and a whole new strategy that favors massive numbers of smart, cheap drones over a few super expensive jets.
And this isn't science fiction, it's happening right now. American Airlines is already using AI to automatically rebook you when your flight gets canceled so you can skip those miserable lines at the gate. And Delta, they're on track to let AI manage 20% of their fares, basically tailoring the price to exactly what it thinks you are willing to pay. This is a huge shift.
Now let's jump over to the defense world. This one quote, just perfectly sums up the revolution that's happening with the U.S. Air Force's new drone program. It's called CCA. See, they're not buying a single all-in-one fighter jet anymore. They're buying the body, the physical airframe from one company, and the AI pilot, the brain, from a completely different one.
And this is where you can really see that power shift in action. You've got a traditional giant, RTX, providing the brain for a General Atomics airframe. But look right next to them. You've got a startup, Shield AI, providing the autonomy brain for Endural's platform. These software-first companies are now playing on the same level as the old guard hardware titans. It's a whole new ballgame.
So, if AI is the new brain, how does the industry solve that body problem, that physical wall of production backlogs we talked about? Well, the answer is something called the digital thread, and it's all about weaving it through the entire factory floor.
A huge part of that digital thread is additive manufacturing, or what most of us just call 3D printing. But forget those little plastic trinkets. This technology has grown up. We're talking about the industrialized, certified printing of flight-worthy metal parts that go directly onto an airplane.
So how does this actually work? Well, instead of a giant, dusty warehouse full of spare parts, you have a digital inventory of part designs just stored in the cloud. When you need a part, you don't wait for it to ship from halfway across the world. You just print it, on demand, right where you need it. This is a game changer. It completely bypasses shipping delays and makes the whole supply chain way more resilient.
Okay, another critical piece of this digital thread is the digital twin. I want you to imagine a perfect, real-time, virtual copy of a jet engine running on a computer. It's being fed a constant stream of data from sensors on the actual engine flying through the air. This allows engineers to see problems and predict failures before they ever happen.
And believe me, this isn't just a cool idea. The industry is all in on this. Look at these numbers. A massive 81% of aerospace leaders say digital twins are absolutely essential for keeping their planes flying reliably. And 75% say they're invaluable right from the get-go, in the design phase, saving a ton of time and money on building physical prototypes. Now, beyond that production wall, the industry is running into an even bigger one, the environmental limit. And to get over it, they're basically running a two-speed race. They're chasing a short-term fix and a long-term revolution, both at the same time.
So, that short-term fix is Sustainable Aviation Fuel, or SAF. But this chart really tells you everything you need to know about the scale of the problem. Even with production doubling this year, SAF will still make up less than 1% of all the jet fuel burned. It's a drop in the ocean.
So you have to ask, why isn't there more of it? Well, the market is completely stuck. You've got fuel producers who won't build these expensive new refineries unless they know someone will buy the fuel. And then you have the airlines running on razor-thin margins who won't commit to buying expensive fuel that barely exists. It is a classic deadlock.
And that deadlock is exactly why the industry is also investing in a long-term revolution. So while SAF is the focus for right now, the midterm goal is hybrid electric power for workhorse jets like the 737. But the ultimate prize, the holy grail, especially for shorter regional flights, is hydrogen power. We're talking true zero-emission flight.
So this new digital-first world is pretty exciting. But let's be real, it's not going to be an easy ride. This convergence of code and aircraft creates a whole new rulebook and some really tough new hurdles to get over.
First up, the regulators. The two big players in aviation safety are taking totally different paths on AI. You've got the FAA in the US being pretty cautious, looking at things case by case. And then you have EASA in Europe, which is being way more proactive, laying out this whole structured roadmap. This split could cause some major headaches for companies trying to sell planes worldwide.
Next up, cybersecurity. And this number, well, it's just staggering. Ransomware attacks on the aviation industry have surged by 600%. And we're not just talking about someone stealing data anymore. With things like GPS jamming and spoofing on the rise, cybersecurity has become a direct threat to flight safety.
And you know, when you ask what's really holding back AI adoption, it's not the technology itself. The biggest roadblocks are all organizational. It's the decades of messy data nobody can access, it's trying to plug shiny new AI into computer systems from the 1980s, and it's a huge shortage of people who actually know how to do this stuff. These are the deep foundational problems that have to get solved first.
So it's pretty clear the future of flight is being written in lines of code woven through that digital thread and powered by AI. It's really the only way the industry can break through those physical and environmental walls that it's up against. But it leaves us with one big question. Is that new digital foundation going to be strong enough to actually support the immense weight of the physical world it's trying to save?